I was developing a chess game in Unreal Engine, and something got me thinking. Is this engine really suitable for such a small game? Do I really need a package size of at least 300 megabytes? And what if I wanted to publish for both mobile and PC? Well, I'd always wanted to give Unity a try and explore what it can do. And these questions pushed me to finally start learning it. But I wanted to start simple. So checkers came to my mind. It's classic, it's simple, it's as boring as chess, so that's perfect. Let's do it and make it a bit more fun. Alright, before I start creating any logic, I usually make some primary assets in Blender. This way, I don't get bored visually in the middle of the process. So I created a simple cube, add a bevel modifier on its corner, and use it as the board. I also make sure to set the bottom left square center as the origin of the mesh. Since the board has only 8 columns and 8 rows, we can set the dimensions to be multiple of 8. For example, I made mine 80 centimeters. Next, I made the cylinder to represent the pieces, and I ensure their origin is at the bottom center, so they don't overlap when we move them in Unity. Now, the reason I chose the board's origin to be different from the actual center is because I want to place it on the word origin 000 in the game engine. To avoid physics glitches later on, I scale everything up by 10 units, making the board 8 meters wide. Since every meter in Unity equals 1 unit, this makes it much easier to place the pieces and move them afterward. So now we can just place pieces at integer coordinates like 00, 31 or 20, as long as both numbers are less than 8. For the colors, I personally find red and silver more appealing than usual black and white, so I went with those instead. Most of the board games you see on the internet are only 2D, and there's a reason for it. But my goal is to make the camera projection orthographic and allow players to move the camera easily. To do that, I created a C# script that controls how the camera behaves. Since I want the camera to always point at the center of the board, I need a placeholder as a transform object to place it right in the very center of the board. Instead of rotating the camera individually, we rotate the placeholder along the pitch and yaw axis. Then, I set a limit on the pitch rotation from 20 to 80 degrees. Firstly, to avoid gimbal lock, and secondly, to prevent the players from bringing the camera too low. Now, when the player holds the leftmost button, they can rotate the camera around the board. Alright, now we need to make the game realize when we clicked on pieces, and also be able to tell the difference between clicking on the board and clicking on the piece. So how can we do that? In Unreal Engine, there were 2 approaches I know of. The first one was an event called onCursorBegin, and whenever the mouse hovered over an object, it would trigger a callback. That was really easy, but in Unity, I guess we don't have that out of the box. Instead, game engines give us the ability to draw a line and see what object it hits along the way. In Unreal, we call this a trace, and in Unity, we call this raycast. We just need to initialize its starting point, its direction, and its length. The problem is that when we click, the game only gives us the cursor position in a screen space. For example, on a Full HD display, we'd get values between 00 and 1920 and 1080. If we know a bit about computer graphics or linear algebra, we know there is a transformation matrix that converts 3D world position into a screen space, and its inverse does the opposite. So we can use this function to transform the cursor's screen space position into a world position, and use that as the raycast starting point. If we then align it with the camera orientation, we can generate a raycast and see which game object we hit. When the raycast hits something, we can save it into a buffer. But here's the problem. If we click, we might accidentally select the board first instead of piece. The easiest way is to use tags to make a clear distinction between object types. Now, when my selected object cache is a null, I can click a position on the board and move the piece there. But we need another space to represent the board clearly. Using just word space or screen space gets messy, so I created the custom board space, which is a simple 2D matrix that uses integers like 1 for black, -1 for white, and 0 for empty. The good thing is, we don't need any complex transformation here. We just ignore Unity's word y-axis and map the word z-axis as the board y-axis. Yeah, I hate Unity's coordinate system. Next, I save the simple movement patterns for each step type, like pawns and kings. Each dimension represents the step the piece takes along the board. With this system, we now know where each piece can move. But there's still one problem. Pieces can move on top of each other. To handle this before moving, I check if the target's location is empty using my state matrix. If it's empty and the move matches the pieces allowed moves that we made earlier, then I let the player move. For white pieces, I just multiply their z-axis by -1 so they can move in the opposite direction. Now that all the pieces can move, we need a component to maintain the game rules. For that, I created a script called Game Mode. You can call it Game Manager. I just follow Unreal Engine's convention. Since I need to access to it everywhere in the code, I use the singleton pattern, which means I made a static variable that holds the class instance. And because it's static, I can access it globally. With Game Mode handling the game state, I can also manage turns easily. I just use a boolean. If it's true, the red player moves, and if it's false, the white player moves. And after each move, I just negate the boolean, so it switches to the other player automatically. Alright, I think that's enough for now. There is still more to do, but we've built the foundation. So I hope you enjoyed this video. Thanks a lot for watching, and I'll see you in the next one.